My name is Julie McMeekin, and my project is on how to find the most aquatic cave organisms. To start off, I'd like to thank my dad for driving me up to Harrisonburg pretty much every weekend. I'd like to thank Mr. Dutton for helping me every step of the way throughout this experiment. And I'd also like to thank every caver that helped me, specifically Dave and Phil Lucas. Without the two of them, this project definitely wouldn't have been possible. So, I got this idea back in sophomore year of Governor School. We visited Luray Caverns as part of our trip, and the whole experience just got me really interested in caves. And so when the time rolled around for us to start senior projects, I contacted the Richmond Area Speleological Society, and I asked if I could come and sit in on a meeting with them to see if I could possibly do my experiment with them. And they said yes, and I first went caving in Butler Cave, and that's the picture on the right. And then eventually that led me to coming up with an idea, and I was actually able to do it in Endless Caverns. Endless Caverns is a commercial use cave, but there's also a lot of area in it that is not touched by tourists. So that's where I did my experiment, and I learned a lot along the way, which I'm very grateful for, and I'm going to talk about it. So, cave characteristics. Most caves have these characteristics, including Endless Caverns. They typically have constant temperature throughout year-round, and they have a lot of unique formations, such as on the left you can see a formation called a gypsum flower, and on the right is a formation called cave bacon. And caves also typically have streams that are connected to the surface. This provides water for the organisms living within the cave. But while this is positive, this can also be a negative, because the cave streams either flow into an above ground water source, or the above ground water source flows into the cave stream. And this can be bad because whatever affects one will affect the other, and typically something that affects one is typically negative, not a good thing. And human impact is also a problem for cave streams. Just for examples like pollution and other things. This can be a problem for the organisms that live in caves, and these might look a little familiar for Governor School students. I know for me, as when we were sophomores, we looked through leaf packs to find benthic macroinvertebrates, and stygobites are basically the same thing, are very similar. They just live in cave streams, and they've adapted to live in that environment, so they have characteristics like minimal pigmentation and reduced eyesight. And these guys are important because, like benthic macroinvertebrates, they can indicate water quality, such as their presence can mean that the water quality is sufficient enough for life to live in. And they also have different tolerance ranges like benthic macroinvertebrates. And so since benthic macroinvertebrates are commonly studied using leaf packs, this method can also be used to apply to study stygobites, given that they have similar characteristics. But this idea is not commonly used for stygobites, so not much is known about it. It's a pretty recent idea, and I thought I would focus on how to find the most stygobites using the leaf pack idea. I had two independent variables for this experiment. One was location, and the other was material. Since Endless Caverns is a commercial use cave, there's a trail that people go in when they're on a tour. And what I did, I went off that trail, and my location hypothesis was that the further I got away from the trail, the more stegophytes I would find, and that's my alternative hypothesis. And my no is that it would be the same no matter what. And for material is the material that I use to make the leaf pack, and I thought that for my alternative hypothesis, I thought that a smaller hole size porosity in the material, the more stegophytes I would find, because smaller ones would be able to get into it. And my null is that no matter the material size, I would catch the same number of stegophytes. And my methods for this is just a simple side view diagram of the cave where I did the experiment. To the left you can see the commercial path. I just marked where that was, and then I went down about 20 meters to site 1 where the stream was first accessible, and then I went 140 meters later back to where the stream was accessible and had a leaf pack there, and then 290 meters after that there was a third leaf pack when the stream was accessible again. And I used the total distance away from the path. So site 1 was 20, site 2 was 160, and site 3 was 450. And so what I did, I placed a pack at each site. I checked it after 2 weeks, and then I checked it again a week later, and then changed the materials at all sites. So each site had the same material at the same time, they were just at a different location. And what I found 11 organisms total, and the first one I found was this isopod. It was about 2 inches long, and it was pretty cool. It was found with the mesh material at the last site. And I found a few more of these isopods, and I also found a cave salamander at the last site using the synthetic fabric material. And my results, on the x-axis I have location in meters away from the path, and on the y-axis I have the number of stegophytes found. The first 2 locations had the same average number of stegophytes found, but the last location had a higher average and a lower standard deviation. And I ran an ANCOVA on this because of the 2 independent variables that I had, and I got, for location, I got a p-value of 0.3020, meaning that location did not have an impact on the number of stegophytes found. For material, I have material on the x-axis and the number of stegophytes found on the y-axis. And you can see that mesh had a much higher average of stegophytes found, and fiberglass and synthetic fabric had the same average and the same standard deviation. And using the same ANCOVA, for materials IV, I found a p-value of 0.0484, and that meant that material did have a significant effect on the number of stegophytes found, but that didn't tell me which material was the best one. And so I did a multiple comparison with a Bonferroni correction, which lowered the alpha value, and found that mesh was the statistically different material. As you can see by the graph, it had a higher average, and that means that I caught more stegophytes using this material. And so to sum that up, location did not have a significant impact on the number of stegophytes found, and material did